Well, since this force is pulling it back in,
Unless you,
it is not the centrifugal or centrifugal force. It is this one. Center. And then PET for seeking. Now, what words do we have in English that have PET in it, meaning seeking or coming together?
petition,
What'd you say?
petition.
Say petition? Quite possibly, not the one I was thinking of. But yeah, I suspect that also is there.
Can you give the next paragraph?
Did I-
Yeah, the next.
Well, I mean, it's, if you have two groups that come together and one of them tries to win, actually both groups try to win.
Competition.
Yeah, that's the one I was thinking of. But yeah, petition, I would think, because you're bringing people together to rally for a cause. Yeah. So that's the one we're talking about. Centrifugal or centrifugal is going away. So if I am looking at this, if I look at the mass that was swinging, I have a force pulling it in. What force was pulling that mass in?
Or the string,
What was the force then?
tension,
Yeah, usually a little less hesitant. Say it like you mean it.
tension.
Then, yeah, there we go. So we have tension acting inwards. Now we'll later talk about it's actually part of tension, not the full tension. But that is the centripetal force. Well, if I have the string attached to it, then I know I've got a tension acting out that way. That is the centrifugal force, as opposed to the centripetal force. The trouble is, centrifugal is often misused. I'm not saying that it can't be used properly, that it should not exist. I'm saying that it is really a false force most of the time. To use it properly, you're either talking about the reaction to the centripetal force, or you're in a rotating reference frame, which is well beyond the scope of Physics 151. So I'm about to erase this, and potentially it's the last time we ever mention this word again. Any questions before I erase it, and potentially we never talk about this word again? The last one. So, we're not changing F-tom. The centripetal force is going to be some part of the forces we already know. So, for example, in swinging it around, it was the tension. The centripetal force is the net force towards the center of the circle. And we don't have enough time to derive it today, so hopefully I'll remember on Wednesday to derive the formula. But if I look at what I was doing as I was swinging it around, it actually was sagging some. What are the forces acting on the mass as it was swinging around? Wait.
Tension.
Acting up at an angle. If this angle here is theta, then that angle there is theta. If it's traveling in a circle at a constant speed, then I know that the net force is towards the center. In which direction is the center of the circle as this thing is spinning around?
It changes.
Excuse me?
It changes where it is as it goes around.
Okay, at this moment, when it's on the far right side or far left side from your point of view, what's the direction?
Towards the right.
That direction?
If it's on the left.
Yeah. And that is. And the biggest mistake students make is thinking it's towards the pivot point. it is towards the center of the circle. This thing is not spinning around like that. It is spinning around like this. And so if we broke, so therefore, that is going to be the direction of the net force. That is the direction of the acceleration. The acceleration is towards the center of the circle that it's traveling in. And again, Wednesday will drive that. So we would break tension up. So going up, we'd have Ft sine theta. Going to the right, we'd have Ft cosine theta. And down, we have the weight. Those would be balanced. That's going to be equal to mass times the centripetal acceleration. And we're going to leave it right there. And let me hand stuff back. I'm going to stop this before I flash a grade.